now. So all you got to do is take notes as we go, and that'll be your math lab assessment points for the day. So, first question. Which of the following statements about the correlation coefficient is true? Select all that apply. I'll make it bigger. It gives us info about the strength and direction of a linear relationship. If R is a correlation between X and Y, negative R is a correlation between Y and X. It's always between -1 and 1, but could be equal to them. The larger the absolute value of R, the stronger the relationship. And then we'll summarize as we go. Once you answer, so you could get like your point for the Kahoot on the game, then you just start taking notes. And then Mason and Natalie just reminding you, don't exit out of your test until you've done it 12. And you need the calculator. Okay, so correlation coefficient, otherwise known as the R value. Don't confuse it with residuals. 3 out of these 4 were correct. So blue is definitely not correct. We've never talked about having to switch the Y and X or something like that. What makes the R value negative? So if I give you a correlation coefficient of like -1, what part of that makes it negative? So that test we took today, the retake's Friday. A lot of people need the retake from what I've seen from the first hour that took it. So let's like lock in to make sure that we understand it. So what about correlation makes it a negative R? When was it ever negative? You know what correlation is? All right, all your headphones away. And I don't want to see you on your phone unless it's for the Kahoot or like the topic. Because I'm telling you, from what I saw on the test scores, they were not good. I had some of my highest flyers scoring a 5%. And I don't understand why. I think this is one of the easiest units. It's very little calculations. It's all conceptual, and to me, it makes perfect sense. When is correlation ever negative? Harley? No, not if it has nothing to do with if it's linear. Linear would be if it's strong or weak. But what about it makes it negative? When does my R value become negative? Harley? Okay, so when X increases and Y decreases, that's when you would see a negative correlation. So negative correlation, this would be like the notes you take that you hopefully use in your studying for this Friday. Anyway, negative correlation is when X increases, Y decreases. A positive correlation would be when X increases, Y also increases. So X is still increasing in each situation. That's why on some of your constructed responses, I'm having to take off points. Like when we ask, like, why is it positive? What makes it positive? Some of you say it goes up. Well, like what goes up? It has to be that the both of them are going up, X and Y. If it's a positive correlation, And then it has to be that it's going down from left to right if it's a negative correlation. Okay, so that's why like this isn't what makes the R value negative. Does it look like it's going down from left to right or up from left to right? That's how you know. But the rest of it is true about correlation. It tells you about the strength and direction. It's always between -1 and 1, and it can be equal to -1 and 1. And absolute value, not sure if you guys remember what that is, but what's the absolute value of -1? What's the absolute value of 1? So these are like your absolute value bars. I know I've told you guys at least about it before. Absolute value of -1 is what? 1. Because it's how far away is it from 0? -1 is 1 away from 0. What's the absolute value of 1? Also 1. So it's not the sign that makes it strong or weak, is basically what's that saying. It's how close the absolute value of R is. So whether it's -1 or 1, in other words, farther away from 0, that makes it strong or weak. So it could be -0.99, and that's still going to be strong because it's close to -1 or farther from 0. Questions on that? Okay, so then on to the next one. All right, data for students showed that as their study time increased, their test scores increased. Take the statement that you can conclude from that finding. Information given to us is that data shows that as student study time increased, so did their test scores. So I'm guessing we're picking the best statement that we could get from this answer. So red was not the answer. What's wrong with what red says? So a longer study time causes them to score higher. So even if it said it causes them to score higher on the test, there's still something wrong with it. So what is wrong? Why can't they say that the study time causes them to score higher? I mean, as one is increasing, so does the other. So is there a correlation? Is there a relationship between those two things? So yeah, correlation and relationship kind of mean the same thing. So there is a correlation. What type of correlation is it? It is a positive correlation because as one is increasing, so does the other. We don't know how strong it is. It doesn't say like that it looks really linear or anything like that. But we know like, okay, there's a positive correlation. That does not mean that there is cause and effect or causation. It's like what you normally see it on as tests. There is not a cause and effect relationship there. Because there can be kids that study a lot and not score well on tests, right? And can't there be kids that don't need to study at all and still score well? So even though that is usually a factor in how you score on a test, there's not a cause and effect relationship there because there's other factors that affect it. Okay, so you cannot say there's causation even if there's a strong correlation. Okay. For the blue, it says this shows a causal relationship. Again, we just talked about that. There's no cause and effect there. There's a strong relationship between them, but there's not enough to say there's cause and effect. Cause and effect would be like this causes this and nothing else. Like sunburns come from the sun only, nothing else. All right. For the yellow, that is correct. There is a correlation, which is just like a pattern. And it could be completely two random variables that have a correlation. Doesn't mean they have causation. And then this one says there's no correlation, but clearly there is. If as one increases, the other one increases or decreases, then there's a correlation there. If it's inconsistent, you can't tell if it's increasing or decreasing, or it's doing both at the same time, then there's no correlation. Questions on that? Okay, so then on to the next one. What does the correlation coefficient of 0.982 on a linear regression indicate? Does that correlation coefficient indicate? Okay, so red should definitely not be it, because if the slope was negative, the R value should also be negative. So correlation coefficient and R value are the same thing, by the way. I use them interchangeably. Don't confuse it with residuals. But the only way the slope would be negative is if the R value is negative, and this is also positive, so definitely not red. Again, there's not necessarily causation unless it's like been a proven fact that nothing else causes that one thing. So there's no other information other than the R value here. The R value could be one exactly, the strongest, and there's still no causation. Okay, so very rarely is there causation. For the yellow, the scatter plot saying that it shows no association. If the R value is this number, which wouldn't you say that it's pretty close to 1.982? It's very close to 1. So then I should expect, and since it's also positive, I should expect it to be going up, but I should expect it to be almost in a straight line. Since it's not 1 exactly, then maybe we have a few points not on the line. So if that R value is closer to 1 or -1, there's a strong relationship there, strong correlation. Doesn't necessarily mean there's causation. Good. Okay. So then next one. What is the appropriate correlation coefficient for that graph? What's the appropriate R value? If that's what the graph looks like. Try. We're doing corrections on it tomorrow. We're taking it Friday. Like we could actually just pull them out. Okay. So there you go. The only way it would be an R value of 1 or even -1, so farther from 0, would be if it was really linear, and this, I can't even tell if it's going up or down. If I drew a line in really any which direction, the points are not all close to it, so it should not be close to 1 or -1. Good on that? Okay, so then R values of 0 would be no correlation. If there are 160 students in 12th grade, what percentage of 12th graders belong to no more than one club? I'm gonna make it bigger. But if there's 160 12th graders, what percentage of 12th graders belong to no more than one club? I mean, that's as big as it will go. For these questions, I really just think you need to read them carefully. Like, there's no way around it. Like, I could throw all this vocab at you, but all you have to do is read it carefully. So if there are 160 students in 12th grade, what percentage of 12th graders belong to no more than one club? So if they belong to no more than one club, how many clubs are they a part of? One. Okay, so, and we're talking about 12th graders. What percentage of 12th graders? Now, this is how many 12th graders are in one club. When it says what percentage of, given that among those out of whatever that population is, you need the total for that population. Notice there's no totals here, right? You could add these up and figure out how many total there were, but it did also tell you in the description. There's 160 total 12th graders. And then out of them, 75 are in no more than one club. If it wants a percentage, how do you convert that to a percent? Okay, divide them, so do that. Wait, did you say divide by 100? Okay, well, first you need to divide these numbers. So 75 division sign 160. And then you're not going to divide by 100. So when I divide these, I get about 0.47. Now it doesn't mean 0.47%. So how do I convert that to a percent? Multiply it by 100%. And then when I do that, I get the right answer of 47%. So first you need to know how to convert your fractions to decimals to percents. That's a skill in itself. And then also just read it carefully. If it says out of a certain group of people, it doesn't necessarily mean all the people that were surveyed. It's just out of however many 12th graders, out of however many people did one club, whatever it is. That should be your denominator. Questions on that one? Okay, remember, take notes as you go. Here's the next one. One person got that, and I wonder if there's no chance to see. But which of the two has a stronger correlation? The one on the left or the one on the right? Okay, better. Not 100% accuracy yet, but better. Stronger has to do with what? Like what, how do I know if a correlation is strong? If it's really close to the line. Now what line, it would be like whatever line that you can draw through the middle of the data that the points seem to be clustered around. Pretend that's a straight line. Okay, so then on the one on the right has that closer to the line of best fit. So that is what makes it strong. Nothing to do with whether it goes up or down. Strong is if it looks more like a straight line or less like a straight line. Okay, so then next one. Okay, which correlation coefficient best matches the scatter plot on the left? So on the left, that scatter plot, what correlation coefficient best matches it? Okay. On a side note, I do have tutoring today, so hope to have your scores in the grade book for the test details and if you need more help. Want to see why you scored that, consider staying after school. But anyway, so our values. Maybe if I draw like a diagram, maybe you'll understand that. So your correlation coefficients are always between what two numbers? What's the lowest number it could be? -1. What's the highest number it could be? 1. So anywhere, including these numbers and in between these numbers is 0, but also like any decimal in between that can be your correlation coefficient. Now, the closer it is to 0, the weaker it is. So if it's like 0.25, that's pretty weak. If it's negative 0.25, that's also pretty weak. The closer or the farther from 0, I should say, the stronger it is. So it's stronger here, and it's stronger here. So you guys already told me that this one is stronger. It asked about the one on the left, so it asked about the weaker one. So we can expect the weaker one to be farther from, and since they're both negative, farther from -1. So like think on a number line. -0.9 would be here. -0.5 would be like here. So I hope you have like that number sense. You saw some questions like that already, where they might have been really close to each other and you had to decide which is technically better. The stronger ones are the better ones. But yeah, so this weaker one has an R value closer to -0.5. And the stronger one would be -0.5. So questions on that one. Okay, so then next one. All right, which correlation coefficient best matches the scatter plot on the right? Again, you could probably have the one the one we just did, but all right, almost 100% accuracy. I don't know, hopefully we're just getting confused on our left and rights and we actually know how to estimate it. I don't know. But on to the next one. Okay, decide whether the following correlation coefficient represents a strong or weak linear association. The value is 2, 7. Would that be a strong or weak linear association? Okay, so 2 7s. I've not shown you a problem like that, but hopefully you could figure it out. How can those of you that got it right, how did you know that it would be weaker, meaning closer to 0 than strong? Did you make the decimal? Did you just know? How did you figure it out? How can you make the decimal? Can you make any fraction a decimal? Dividing the numerator by the denominator. The fraction bar means divide. So 2 divided by 7. And you get about 0.29, which then maybe that's easier to compare, whether it's closer to 0 or 1. All right, we're on the next one. All right, decide whether the following correlation coefficient represents a strong or weak linear association. 100% accuracy on this, I hope. Okay. Yeah, I don't know. At this point, I feel like people are just not caring. Like, we just talked about it all day. Why is that strong? Harley? It's further from 0, and you're limited to everything between -1 and +1. So farther from 0, stronger it is. Next one. Okay, so decide whether the following correlation coefficient would have a strong or weak linear association. Okay. Okay, better. That's the strongest it can be. So, well, I mean, I guess -1 is also equally as strong, but yeah. When it's 1 exactly, then that means all the points would be on the line of best fit going through the middle, like not the edge of a point. Okay. So decide whether the following correlation coefficient represents a strong or weak linear association. -0.15. Okay. All right, we're getting better. So not 100%. It's the same 3. I don't know. I feel like, are you like purposely picking the wrong one? I don't know. But that's closer to 0 than it is to -1. Therefore, it is weaker. All right. Think of it like change. I don't know. The decimals, think of it that way. Okay. Decide whether the following correlation coefficient represents a strong or weak linear association. Now it's 8/9. Okay, good. So that's pretty close to 1 because it's almost close to like 9/9, which would be 1. Or if you did the decimal, I think it's about 0.89 if I remember from earlier, which is still strong. So we're getting better, almost there, almost to 100% accuracy. 400 students were surveyed. Of the 250 girls surveyed, 150 attended the show. Of the boys surveyed, 75 attended the show. You're doing this on your paper. Sorry, I'll try to make it bigger, the table, but really you're just making a two-way table based on that info. So we have for the rows, attended, did not attend, total. For the columns, it's boys, girls, total. We need to review the two-way tables. I'm so surprised that that was a big issue earlier. Ryan? Whenever you're having to fill a two-way table, start with what they give you. So literally from left to right when you read. 400 students were surveyed. So if I want my 400 students that were surveyed to be in my table, where in the table would that go? Total, there's 2 totals, so which total? Okay, bottom right. And assuming that you have like a total column and a total row, that bottom right corner would always be your total survey. And this one is 400. If you don't have a total row or total column, consider adding that like a scratch work on your test. Because then you can answer some other questions that you might need to. But so 400 students were surveyed. Of the 250 girls surveyed, so they're telling us 250 girls were surveyed. Where should that go? Next to the 400, like to the left. So that's my total girls survey. I know there's more after that, but we know 250 girls were surveyed. So I need to put that where it's girls and total intersecting. But of those 250 girls surveyed, 150 of them attended the show. So where do I put the 150? Right under this heading of girls. That's the ones that attended the show. Girls that attended the show. Then we have of the boys surveyed, they didn't specify how many boys were surveyed, but of the boys surveyed, 75 boys attended the show. So where does the 75 go? We say bottom right here. Yeah. Okay, you guys agree? Does 75 plus 250 equal 400? So then that must go somewhere else then. So of the boys surveyed, 75 attended the show. So under boys right here. Make sense? Okay. Now the rest we have to figure out, but you can do that with like your critical thinking skills. It's like a puzzle. So you need to know that the rows add up to the row total, the columns add up to the column total. So what can I add in based on what I have currently on my table? The total that attended the show, because then I just need to add 75 and 150 with 75 plus 150. Okay, so then that's what we'll go here. What else can I fill in now? The total boys right here. And I can't figure it out from this space, the column, but I can figure it out from the row. What math do I do? Which is, okay, good. What else can I figure out now? All the middle ones. Whichever one you want to start with. Which one? Okay, for the girls, how many girls did not attend the show? 100, and I know that because you would have had to do 250 minus 150, that's 100. These need to add up to this total, right? So what else can I fill in? The boys that did not attend the show, which is how many? Good, because that would add up to 150. And then what is this piece that's missing? And you could do that from adding this, but I would also just make sure that it makes sense over here. Like I need to make sure the 225 plus 175 is also 400, because if it's not, then I made a mistake somewhere. That makes sense? Okay, so then that covers that. Any questions? All right, I know the test had some stuff that was like maybe a little bit harder, but otherwise I feel like you guys should be able to tell me what 1/15 of 160 is or whatever it was. All right, anyway, next one. All right, which situation describes a causal relationship? You're gonna have to read that. Don't be lazy. And just guess if you don't want to read it. You said you're done, Natalie? Come put it in this file. You don't. That's only on paper. I'm only make that with a calculator. All right, so those of you testing, we have 8 minutes left. Okay, so causal relationship means like cause and effect. Like there's nothing else that could probably cause that. So don't just assume. All right, so for the red, the higher the volume on the radio, the better the song. Is that always true? No. You could listen to a song that you like very quietly, so that's why it's not red. The faster a student types a paper, the more pages the paper will have. Is that always true? All right, no. That just means that it probably won't take them as long to type the same amount as someone else if they type really fast. Has nothing to do with how much that student has to do as far as work. So that's why it's not blue. Doesn't mean that you'll have more pages just because you type faster. Maybe after a certain time frame, yeah, but that's not what it said. Then for the yellow, the shorter the distance driven, the less gasoline that will be used. Can you guys think of times where you use more gas than this distance? I know you guys don't drive yet, but like when you start up your car, you're not going any distance, but that's using gas in itself. Like when your car is just like warming up. When you're sitting in traffic a really long time, that uses more gas, even though you're not necessarily traveling like as far of a distance. So that could happen. The green one is the better one. The slower the pace of the runner, the longer it'll take to finish the race. Those have a direct cause and effect. Questions on that? Okay. So then we have, which of the following statements about residuals are true? Find residuals by subtracting actual x values minus predicted x values. Residual plots determine if the function is a good fit or not. When line of best fit for data is linear, residual plot will look like the line, and sum of residuals should be 0 because predicted should be close to actual. Some of these I phrased differently, but just do your best. So let's all that apply. Okay, so blue and green are both true, although I probably phrased some of it differently. Red, it sounds like one of the things you learned, but what it would actually have to say is that you subtract the actual y values minus the predicted y values. Y values would be your outputs, so that's what we care about, not the x values. X values should be the same in each situation. Residual plots do determine if the line of fit is good for the scatter plot or not. How do you know based on the residual plot if it's good? Where should it be close to if it's good? Which line exactly? So like a question on your test, and I told you when you did the notes, and I told you when you did your homework, you see something like it again. How do you know based on just a residual plot if it's a good fit or not? The closer it is to not the line of best fit, I mean, residual plots hover around what? So it looks something like this, and you see a bunch of dots. Even though your line of best fit could be like way up here and your data way up here, your residual plot is always near your x-axis. So the closer it is to your x-axis, the better the line of fit is. So that's what that means. And that's also why we want it to be closer to 0 for some of the residuals, because that means the actual and predicted are closer. So let's see our rankings. So Cohen, you have your choice of 5 math lab assessment points, candy, or a homework task. Okay. Kadisha, you have your choice of math lab assessment points or candy. All right. So then, Frankie, you get some math lab assessment points. All right, you said you can come take your math or candy. All right, better scores. Consider coming to tutoring today. You'll see your score later, before school ends, at least on the Illuminate part. Yes. Yeah, so